Hey everyone, welcome back to Loot Code. Today we will be discussing another sorting algorithm called Insertion Sort. Alright, so let's dive into it. So this is a given array, okay, 5, 3, 2, 4, 1, and n is the size of the array. Alright, so 5 is the size of the array. Now, first we will divide this array into two parts. So that a of 0 element is one part and a of 1, 2, 3, 4, this is another part. Now I will call the left half as sorted list and the right half as unsorted list. Okay, now the first step that we're going to do is we'll observe a of 1. Okay, a of 1, and we will store this element in temp a of 1. We'll create a variable called int temp and we will store that element 3 in temp. Okay, now what we're going to do is we'll go to the sorted array and we will compare this 3 value with the element in the sorted array, and based on where it's supposed to be, if it's greater than, it will remain where it is. If it is lesser than, it will shift to the left side of that element. Okay, so we're going to check this temp. We're going to compare this 3 and 5. 3 and 5 we will compare, and then after comparison 5, since 5 is greater than 3, 5 will shift, it will right shift. It was at a at 0, it will right shift to a of 1. So 5 will come here and the rest of the elements will remain intact for 1. Now there is no element after 5 in the sorted array, so we will insert this 3 here. So this is 0, 1, 2, 3 and 4. This is 1. Now this is the array. And now 3, 5, this part of the array is the sorted list and this part of the array is the unsorted list. Next, what we're going to do in the next iteration, we will take this element a of 2. Okay, a of 2 is now temp int temp is now equal to 2. First we will compare 2 and 5. 5 is greater than 2, so it will right shift. Okay, I'll write the array here. 3, 4. Okay, so 5 was greater than 2 and 5 was at a of 1, right? 5 was at a of 1. 5 will get right shifted to a of 2 because 5 is greater than 2. Next I will compare 2 and 3. Okay, 2 and 3 will get compared, and is 3 greater than 2? Yes, 3 is greater than 2. So 3, which was at a of 0, will get right shifted to a of 1. And then 2. Now 2 will get stored in a of 0. And the other elements will remain intact. Now this is the sorted list and this is the unsorted list. Okay, next here, this is the array we have right now. Next what we'll do, we'll take this element a of 3. That will become temp now. Temp is equal to 4. Temp is 4, 2, 3, 4. Okay, and now we will compare temp. Okay, with, so temp is 4, so we will compare 4 and 5, 4 and 3, 4 and 2. So is 5 greater than 4? Yes, it is. So 5 will get right shifted to this place, 3, 2, 1, 0, 4. 5 will get right shifted. Now is 4 greater than 3? It is not. So 3, which was at a of array of 1, will not get right shifted. So as soon as 4 becomes greater than 3, okay, so the previous elements will not get right shifted. 4 will come and sit here and the other elements. So now after I've compared 4 and 3, I don't have to compare 4 and 2 because 4 will obviously be greater than 2, right? So the previous elements were already sorted, so it will not go behind 3. Okay, so now this is the array that we have. Next, or before that, this is the sorted list, and this is the unsorted list. Now temp will become 1. Temp is equal to 1, and temp will be compared with 5, 4, 3, 2 Yeah, that's about it. Okay, so this is the array 3 4 0 1 2 3 4. Now temp is 1. We had 5 at a of 3, 1 at a of 4. Now is 1 greater than 5? No, it is not. I mean 5 is greater than 1, so it will get right shifted. 5 will sit here, 1 and 4. 4 is greater than 1, so 4 will also get right shifted. 4 will sit here. 3 is greater than 1, 3 will get right shifted. 3 will sit here. 2 is greater than 1, 2 will get right shifted and sit here. And then 1 will get its place at a of 0. So this is how insertion sort works. Okay. Hey guys, now let's take a look at the code for insertion sort. Alright, so let's take an array, for example, 5 3 2 4 1. This was the example that I've taken in the video. Alright, so let's begin coding. Hash include stdio.h int, or the function won't return anything, so void sort, and the parameters will be an array and the size of the array. The first step will be to run a for loop for int I equals 1. Now I is equal to 1 because if you remembered, the ARR of 0, the 0th index was the sorted part of the list, sorted list, and from I is equal to 1 to I is equal to n was the unsorted list. So the first for loop is for that. Okay, I is equal to 1, I less than n, I plus plus. Then we took a temporary variable and stored that a of 1, right? So int temp is equal to ARR of I. Then int j is equal to I minus 1. Now this j element is to access the sorted part of the array. So if I is 1, j will become I minus 1, which is 0. So that is now a of 0. Alright. Now while j is greater than equal to 0, greater than or equal to 0, and ARR of j is greater than temp. This is where the comparison happens. First we'll check if j is greater than or equal to 0, because we don't want to exit the array, because 0 is the first element, right? ARR of 0 is the first element. So j should be greater than or equal to 0 and ARR of j should be greater than temp. That is when we'll enter the for loop. Okay, because if it is not greater than temp, the right shift won't be happening. This while loop is to do the right shifting. Okay, so if ARR of j is not greater than the temporary variable that we have stored, then we simply don't have to do the right shifting. So now ARR of j plus 1 is equal to ARR of j. This is the right shifting statement where we'll be shifting ARR of j to ARR of j plus 1 if ARR of j is greater than temp, and provided that j is greater than or equal to 0. Then we will decrement j, because we are comparing from right to left, right? So we will, in the sorted part of the array, so we will compare from right to left. So that's why we will decrement j. Then if we are not entering the while loop, it will be ARR of j plus 1 equals temp. This step is when we have finished comparing and we want to put the value of whatever is there stored in the temporary variable to one of the positions, right? So this is going to be the function for insertion sort. Now I'll write the code to print the array in the same function. Okay, so for int k equals 0, k less than n, k plus plus, printf %d, I'll give a space for it to look better, and this will be ARR of k. So this is the sort function. Now we'll go to the main function. Int main, int ARR equals, let me copy paste these values, 5 3 2 4 1 in that order, paste. Then int n is equal to size of ARR by size of ARR of 0. Now I'll call the function sort, and pass the values, pass the array and n, and then simply return 0. Let me save and run the code now. So the array is 53241 and we have to sort this array in the ascending order. Okay, so now if I run the code, and there you go, this is the sorted array 1 2 3 4 5. We have successfully sorted this array 53241 using the insertion sort technique. So once you've gone through the explanation of the code before coding, I would strongly suggest you to take a pen and paper and iterate through all the iterations. Take an example, take an array of your own, and go through this function, and that is when you'll be able to understand.